Thank you so much, Anna. And it's really a privilege for me to be here and to make this presentation for you. I enjoyed immensely the conference. I think there were very, very interesting presentations, which brings me to a little word of forewarning. EASA, the organization I work for, we act as a regulator for safety in an EU context. In that context, we are not really concerned, and we don't try to do any apportionment of liability on a civil side. We are more worried about the public side. We are worried about establishing safety standards. We are worried about establishing clear roles and responsibilities for the actors, but we are not really concerned or trying to influence afterwards what is the result of civil liability in case something goes wrong. So my presentation actually is a bit different from the presentations you've seen until now. I will try to give you a brief overview of EASA because I thought that maybe some people in the audience may not have a good idea still about what EASA is doing, especially in the field of ATM, since it's quite recent. I will give you a brief overview of the standards that we already have and the projects for new standards that we are going to adopt. And in the end, I will talk to you about what we call our automation policy. Because in fact, we have been working on an automation policy since 2009. And I would like to give you some indications of what we are working on when it comes to automation. So EASA, what we are an European agency. We are technically independent. We have legal and financial autonomy, and we have been there since 2003. Our geographic scope covers all the EU states, plus the 4 EFTA states, plus some other states with whom we work on the basis of either bilateral safety agreements celebrated between the EU and third countries, or working arrangements that we have celebrated with authorities from third countries. So it's quite a wide scope. When it comes to the material scope, since 2009, we cover basically everything when it comes to civil aviation safety. Our initial scope, which started with our first regulation, our first basic regulation, 1592-2002, only covered initial and continuing airworthiness. So we're only talking about products, aircraft, how to design them, how to certify them, and how to maintain them airworthy. In 2008, there was a first extension of our scope of competence to air operations and air crew, so flight crew licensing. We have, in the meantime, already published a regulation air crew. It was published at the end of 2011, and it covers everything when it comes to both pilot licensing, cabin crew qualifications, and everything that goes around with that. So also the medical side, and the organizational side. And in 2009, the last extension happened. It was actually linked to the CES2 package, to the safety pillar of the CES2 package, and this second extension was for ATM ANS and airdromes. What are our core activities? Well, the first one I would like to mention is product and organization certification. So we are actually responsible for issuing certain certificates and certain organization approvals. So in the field of product certification, we are responsible for issuing type certificates and for approving design organizations. In the field of in other fields, for example, in ATM ANS, as well as in OPS and FCL, our scope is reduced because, in fact, what we do is basically approve organizations and approve organizations that are located outside the territory of the member states. So when it comes to ATM ANS, our competencies are to approve either ANSPs or training organizations for air traffic controllers, which are located outside of the territory of the EU. And when it comes to ANSPs, there is an extra element, which is that we are also competent for certifying service providers that have a pan-European scope. Then another one of our major core activity is rulemaking. And in this sense, we have two basic responsibilities. One is to prepare opinions, so proposals for the Commission for new rules, either to amend the basic regulation or to create or amend the implementing rules. So basically, we have our own rulemaking procedure, and we follow this rulemaking procedure to come up with an opinion that is sent to the Commission and then transformed into a Commission proposal to follow the normal legislative process. And a second competence that we have is that we actually have been given directly the competence to adopt what we call soft law. So in here we are talking about acceptable means of compliance, guidance material, and certification specifications. And these are non-binding standards that help to implement the binding EU rules. Another of major tasks that we have is standardization. And with this task of standardization, what we do is actually check how member states are implementing EU rules. So we go and visit the authorities, the competent authorities of member states, and we go there with a view to see how they are implementing the rules and to try to harmonize that as much as possible. Something else, which is our international cooperation activity, which I already mentioned because of when I told about all these states that we are cooperating with, but it also means cooperation with international organizations, namely ICAO, where we assist the Commission and the Member States to try to come up with common positions on a European level. And finally, something that is also quite recent, which is called the European Aviation Safety Program, which is like Europe's response to the ICAO requirements on state safety programs. ICAO has come up with SMS and SSP, and in Europe, for our states to implement the requirements for state safety programs, this required some sort of activity at the EU level, because in fact, we have a distribution of competencies between the national and the European level. So the European Aviation Safety Program, what it does is to establish the main European safety priorities and safety targets that then are going to be used by the member states to develop their own national programs. Because we have such a wide scope when it comes to aviation safety, what we have tried to adopt when we develop our rules is what we call a total system approach. And this total system approach is actually based on the conclusion that all components in aviation, whether you're talking about products, services, people, they are all part of a single network that has to work together. And when you are regulating one of the parts of this network, one of these components, you need to take into account all the other components in order to achieve an optimal level of safety. And this total system approach, you can see it reflected in the content and in the structure of the rules that we have proposed. And basically the idea is to avoid safety gaps and also to avoid conflicting roles or responsibilities or requirements. So the idea is that everything is going to be part of one harmonized system. This slide shows you our regulatory structure. So as I already mentioned that in the EASA system you have EU regulations, so you have our basic regulation 216/2008 and then several implementing regulations. These are EU regulations, which means that they're binding and directly applicable in all the member states. And then we have what we call the EASA soft law, so the certification specifications, the alternative means of compliance, and the guidance material. These are non-binding, and they are developed and they are adopted by us as a way to help both industry and the member states to implement the standards or the binding standards in an harmonized way. This may be a bit small to see, but this is a very basic structure of our regulations now. So you see on top you have the basic regulation, and then you have one main regulation for each area that we, or main regulations for each area that we follow. So you have, for instance, there in airworthiness, we have a regulation on initial airworthiness and one on continuing airworthiness. These have been in place since 2003. Then you have flight standards, and within flight standards we include both FCL and OPS, so both flight crew licensing and OPS, as well as a regulation that is still going to be developed. It's called TCO, it's third country operators. And then, which is probably more interesting for you, you have the part on ATM ANS. And here, we already have several regulations in place. Because in fact, just after the 2009 and the extension of our scope, we were asked by the SES committee and by the Commission to develop very fast implementing rules for ATCO licensing, for requirements for the certification of ANSPs, and requirements for competent authorities or NSAs when they are developing their oversight function. And the idea was then to replace the regulations that already existed under the SES, a regulation on ATM ANS providers and a regulation on competent authorities, so what they need to do. These regulations, what we call this first phase of ATM regulations, was very based on what already existed under the SES system, and we are currently preparing a second version or a second phase of this. A bit more the structure of our other regulations, follow the total system approach, and we expect to publish the first notice of proposed amendments during this summer. Another regulation that already exists under this framework is that regulation that you see there, AUR, that is on airspace usage and ACAS 2, and it was also published last year. And there is a final regulation that is going to be developed a bit later, which is, in fact, probably one of the most interesting ones for this audience, which is regulation on systems. And this is about the requirements for systems that are going to be introduced in ATM ANS. So how those systems need to be designed, how those systems need to be built and operated. And that is something that is going to come a little bit later. Something that I would like to emphasize about these ATM regulations that we already have is that the structure that they follow is similar to the structure that all other EASA regulations follow, meaning that for each field, for each area, we are going to clearly identify roles and responsibilities for organizations and for competent authorities, and we are going to have also what we call technical requirements. So basically the technical requirements are going to tell you what needs to be done. The requirements for organizations are going to say how an organization needs to work, how it needs to develop its activities, and the requirements for competent authorities are going to say what the competent authority needs to do when it certifies and when it ensures oversight over the system. Now, to go into the EASA automation policy. I have to say that when we started working on this automation policy back in 2009, it was very, very much focused on aircraft. It was very much focused on cockpit automation, because that was, in fact, what we were working with at the time. But later, with the second extension, the extension to ATM ANS, and also as a consequence, of course, of the total system approach, we are now working also on extending this policy to the field of ATM ANS. But it is true that when it comes to aircraft and what happens in the cockpit, our findings are more advanced. So, in fact, we felt the need to work on this when we realized that modern aircraft, modern aviation is increasingly reliant on automation. And in fact, automation has shown shown many advantages. It has contributed to an improvement in safety, and it has increased also the efficiency of the system. It will become even more important in tomorrow's aviation system. And if you think about CESAR and next-gen programs, and you see, and all we've been discussing today, you see how the tendencies for automation to become more and more important. And it's going to be applicable not only to aircraft, as we were talking about in the beginning, in EASA, but also to ATM-ANS. And despite all the advantages of automation, we need to recognize that it also has many challenges. And one of the challenges, well, basically the two main aspects of the challenges that have been identified is that automation by its own nature and by the interface of automation with humans, there are two major risks, and one is incorrect interaction of the human with automation, and the second one is an over-reliance of the human with automation. So we have been working on this, and it's one of the actions coming from the European Aviation Safety Plan. You can find it on the link that I included in my presentation. And we have been cooperating on a European and international level with other regulators in industry, and we actually have the plan of raising this issue at ICAO very soon. What we have been doing, we have been trying to map several issues, so human automation interaction issues, design, certification, and training principles, as well as regulatory provisions to try to identify issues and, at the same time, paths for improvement. The basic principle that we follow is this system performance principles. And in this system, you see that procedures, design, and competencies need to work together to ensure the performance of the system. In this model, also what is important is that all elements contribute to the man-machine system, and the cause of a breakdown in the performance cannot be reduced to a single component. It's always a systemic approach. We have, based on this mapping that we have done, we have seen that our system is actually globally very well defended, provided that the regulatory provisions and best practices are followed. And it's also true that a lot of improvement is going to come out of these new regulations that are about to come out already in FCL, in OPS, in ATM, ANS. But we still have identified some issues for further attention. And like I told you, these two main challenges of incorrect interaction with automation and over-reliance on automation can be afterwards declined into other issues. One, for example, is that in a very automated system, you run the risk of having a decline of basic manual and cognitive skills of the human operators. And this is something that needs to be addressed. Another thing that we have identified that we are concerned about is that when you are dealing with an automated system, it is possible you run the risk of losing situational awareness of the automation mode and the automation status. And we've seen cases like this. For example, when we were talking about the Überlingen case, there was the air traffic controller was not aware that in fact there was a degradation in the automation. So he was working with a degraded system and he was not aware of that. Another risk that needs to be addressed is the risk of distraction. And that's why it's so important that the level of involvement of the human is a correct level. That's why it's so important that automation takes over the tasks that you were talking about, the repetitive tasks, but that the more challenging cognitive tasks are left to the human to ensure a level of involvement that promotes awareness. Another issue that we have identified is a difficulty in transition to degraded modes. Exactly the same thing. You are transitioning to a degraded mode, and then you don't know how to interact with the system in the degraded mode. and of course, the reaction to an unexpected behavior from the machine. How do you deal with that as a human operator? We believe that these issues need to be addressed via some high-level principles that are looking at design and certification, training, very important, and operations. So how you design the system, how do you train the human to handle the system, and how do you establish the procedures to operate the system. And these high-level principles, you can find some examples there on the right side. Automation should be used at the most appropriate level, meaning choose which tasks should be automated and which tasks should be left to the human. The system should be designed to be error tolerant, and the automation must not reduce the overall system reliability, and at the same time enhance safety, efficiency, and economy. It's a high-level request. When it comes to paths for improvement, we have identified several things that can be done. One, of course, is to enhance basic manual and cognitive skills. But on the other hand, maybe it will be even more important to reinforce a link with automation in the training and the testing that is provided to the human operator. So focus more when you are training a pilot, when you are training an air traffic controller, focus on the link with automation, learning how to deal with automation, learning how to recognize the behavior of automation, learning what to expect from it. The other thing is the organization's automation policy, and we have actually published a safety information bulletin about, in this case for airlines, but asking airlines to have an automation policy within the organization. So each organization to define its own policy on how it deals with it. And of course, another thing is, of course, to look at the standards again, to reassess the assumptions that were made in relation to human capabilities and take appropriate action when necessary. The improvements that we are talking about can be achieved by different means, both on the regulatory side, so we could think about the development of new rules or different rules, but also there is a very important role of safety promotion here. And safety promotion, we are talking about things like the publication of information leaflets, the publication of safety information bulletins, but also, training and any activity that actually can raise awareness of the issues. I would also like to draw your attention that we have actually published a survey on automation on 24 April of this year. This survey will be online until the 30th June, and everybody is welcome to comment. It is, again, very much focused on cockpit, but I believe that the results of this survey can actually afterwards be transposed also to other areas. And we, of course, will continue to develop work on this issue to achieve a higher level of safety, both through the development of regulatory material and standards and through the development of best practices. And this concludes my presentation. Thank you.